Hey there, Stover here, and we're going to continue our conversation on solutions. And so what we should have learned are a few things. One, solutions are two or more substances joined together to form homogeneous mixtures. Two, and this is what we're going to talk about today. We're going to talk about homogeneous. Two, you should have learned that most chemical reactions happen in solution. Remember, our blood, our drinks, even our food, most chemical reactions happen in solutions. Three, you should have learned that solutions are made up of two specific parts. Remember what those are? They are a solute and a solvent, and this is all going to get together and equal a solution. Now, a solute is what is being dissolved, and a solvent is what is doing the dissolving. This is in the least amount, and this is in the most amount. And you can measure these, and we'll talk about that later. Four, you should have learned how to pick out the solute and the solvent. You should have learned how to pick out what is being dissolved and what is doing the dissolving. And then finally, you should have learned that water is considered the universal solvent. Universal solvent. Make that green. Water is considered the universal solvent. Why? It's because water is a polar molecule that dissolves many different solutes. Okay, today what we're going to learn to do is, here's our question for the day. How do we pick out a solution? So that's our question. So in order to do this, we kind of got to backtrack a little bit. So let me give you kind of like a flow chart. Okay, here it goes. Pretty much everything we see is made up of matter, right? And matter is anything that has mass and takes up space. Okay? So if you want to learn to pick out a solution, you have to know a couple different things. And to know those things, you can ask yourself a couple questions. One is, here's the question: can it be physically separated? Okay? And that just means, like, say, for example, you're brewing some, coffee. Where do you put that coffee? You put that coffee in a filter, right? And we're going to make the coffee a little dark here so you can see it. Put put that coffee in this filter, and you can create a cup of hot coffee. You can create a cup of, and we'll make that really dark right here. See if we can even see it. Make a cup of coffee, right? And so you can physically separate that stuff. And we'll talk about how to separate solutions in a few. But we ask ourselves, number one, can it be physically separated? And if the answer is yes, then we are on track to discover our solution. Okay? If the answer is no, then we are on track to figure out what is going into a solution. So if the answer is yes, it can be physically separated, then you have what is known as a mixture. A mixture. Okay, remember this is a flow chart. If the answer is no, then you have what is called a pure substance. Pure substance, right? And so inside of mixtures, you'll discover right off the bat what I'm talking about. If you can physically separate a matter, then you will have a mixture, and there are two different types of mixtures. There is a homogeneous mixture, and a heterogeneous mixture. Okay? A homogeneous mixture or a heterogeneous mixture is visible parts. And so you can see these visible parts. We can think of things like salsa. You can see the tomatoes and the cilantro and the onions. Another one is going to be chocolate chip cookies, or ice cream. You can physically see the chocolate chips. And so that is going to be a heterogeneous mixture. The word heterogeneous literally means different, right? You can see the different parts. The word homogeneous means same. And so you need to write this down. A homogeneous mixture is actually a mixture that is uniform throughout. And what that means is you cannot see the parts. You can't see the parts. A good example of a homogeneous mixture is the air that we breathe. Like you can't see the oxygen or the nitrogen or the hydrogen. You can't see the ozone, the O3. You can't see the carbon monoxide. You can't see that. It's all universal throughout. So it all looks like just invisible air. Okay? Another homogeneous mixture could be considered hydrochloric acid, and that is mixed in H2O, water, and you can't really see the hydrochloric acid or the H2O. You can't see the different parts in there. It all joins together to form a uniform or a same mixture throughout. A couple other homogeneous mixtures. We always hear the term homogeneous milk. Milk is actually not completely homogeneous. Even though you can't really physically see the parts, you can physically separate them. But milk is a good example of a homogeneous mixture. You can't really see the different parts that make up milk. It's all just simply white. Right? Homogeneous mixture. Another one, homogeneous mixture, would be, say for example, we could say it's going to be brass, and that's a mixture of different metals, but you can't really see the different metals in there, but you can physically separate them. Okay? You can physically separate them. So that is a really good question to ask. Can it be physically separated? So these are homogeneous mixtures. So a solution, remember, is two or more substances joined together to form a homogeneous mixture, a mixture where you can't see the different parts. Now, what goes into these different parts are going to be pure substances. And you have two different types of pure substances. You have compounds, and then you have elements. And compounds are simply elements joined together, like CO2 or H2O, or let's say NaCl, or H2SO4, sulfuric acid, or H2PO4, phosphoric acid. So these are compounds. These are two or more elements joined together. It could also be molecules. O2, it's a compound. N2, remember these are diatomic molecules. F2, these are compounds, okay, molecules. So an element would just simply be those things like Na, magnesium, bromine, arsenic, iodine. These are the single elements that are on the periodic table. And so you have these pure substances. And so if you ask yourself this, can it be physically separated? Then now these can be chemically separated, but they can't be physically, like you can't physically pull out the oxygen out of carbon dioxide. You can't physically pull out the hydrogen out of the water. These are chemically joined together to form new substances. You can't pull out the Na out of Na. I mean, basically, it is you can't physically pull it out, right? So a solution, remember, is a homogeneous mixture. And this is a good way to figure out what is a solution. You start with matter, right? And if it can be physically separated, you have a mixture. But a heterogeneous mixture is not a solution. It's just a mixture, and it's a heterogeneous mixture. But a homogeneous mixture is a solution, right? It's a solution. So you can figure that out. And these are what goes into a solution. These are the solutes that go into a solvent to make a solution. And so if you want to pick out the a solution, you kind of follow this flow chart to pick it out. And that means you could also pick out what is not a solution. What is a pure substance? What is a compound? What is a heterogeneous mixture? What is a homogeneous mixture? Like, we could pick those out. So let's go back and review. What we should have learned, one, is that a solution is two or more substances joined together to form a homogeneous mixture. Okay, you should have learned that most chemical reactions happen in solution. You should have learned that a solution is made up of a solute and a solvent. A solute is being dissolved, and a solvent is doing the dissolving, right? You should have learned that water is considered the universal solvent because it's a polar molecule and it can pull apart many different solutes. You should have learned how to pick out. You should have learned how to pick out the solute and the solvent. You should have learned to pick that out. And then now you should have learned how to pick out what is a solution. So, and if you just follow this flow chart, you should be able to pick out what is a solution. So anyway, Stover, I hope this helps. In the next video, we are going to discuss a little bit more on how to measure